Hello, before we get into the video, let me introduce my name. My name is Venerana Baby Violatio. Special thanks to Miss Anna Fitriana SEMM as our lecturer for Mathematics, Economic and Businesses. This is our video explanation about derivative function. So, derivative function, there is two parts for this explanation. There is first derivative function and the second one is partial derivative. For the first derivative function, my partner Rian Hidayat gonna explain about the first derivative, and for my other friend of is Mary Andani gonna explain about the rules and the meaning of those first derivative function. And for my other partner is Charlie. He's gonna explain about the example of those each rules for the first derivative function. And for last, I'm gonna explain the equation of first derivative function. So for the second part of the derivative function, there is partial derivatives. My partner Barry Andani will explain about the partial derivatives. Rian Hidayat will explain about total differential and the implicit function. And for my other partner Charlie will explain about those each example of those partial derivatives, total derivatives, and the implicit function. And for last, I'm gonna explain about the equation of those which partial derivatives, total derivatives, and those implicit function.
Decrease in function, or also might be referred to as differential, is another function of a previous function, such as an f function made f function that has values not using the rulers and result. From the function will change according to the entered variable, or in general an amount that changes over other changes. The process of finding derivatives is called differentiation, or the original understanding of algebra is an extension of mathematics. That's formula f dalam kurung x sama dengan ax pangkat 4 ditambah bx pangkat 2 ditambah cx ditambah d. F action dalam kurung x sama dengan 4 dikali ax 4 dikali a dikali x dikurang x pangkat 4 dikurang 1 ditambah 2 dikali b dikali x pangkat 2 kurang 1 ditambah 1 dikali c dikali x 1 kurang 1. Formula ketiga, f action dalam kurung x sama dengan 4ax pangkat 3 ditambah 2bx tambah c.
Alright, since we already know the general formula of the derivative function, that is fx equals axn, and the derivative of fx or f prime x equals an xn minus 1. N is a power of number. So here are the examples. The first example is fx equals to 3x cubed. So we're going to search for the derivative. So f prime x equals 3 times 3. So 3 is actually from the cube. So we put it down. So 3 times 3 equals 9. So 3 times 3x cube. The cube we minus 1 because in the formula it's how it is. So 3 times 3x cube minus 1. So it gives us 9x squared. And next is the second example, and that is gy equals negative 5y negative cube. So it's actually the same. So g prime y equals negative 5, and we times it with the negative cube, the power of number. We put it down, we times it with negative 5, and we get 15. So that leaves us with 15y, and remember the negative cube we minus it with 1, so it leaves us with negative 4 because it's negative 3 minus 1. It adds the number but it's still negative, so 15y the power of negative 4. So the answer is 15y power of number negative 4.
Hello everyone, my name is Melody. I'm here to explain what MUS are the first things question, the understanding of the codec, and what they are as component as radices. Okay, first, number 1, differential constanta. Y equal key constanta is that dy per dx equal 0. The constant function is the function with f from open brackets x close brackets equal n with n equal real number. Number 2, differential line function. Y equal xn semicolon n equal constanta then dy per dx equal nx per n minus 1.
And for the first derivative rule is constant differentiation. So constant means it's a constant number that don't have any variables. And in derivative function, every number without variables is equals to 0. For the example, y equals 6, and we're searching for the dy by dx, and that's 0. dy by dx is also have the same meaning with f prime x or y prime because all of them is derivative. So if a constant number without variables like x, y, z, and etc., it includes as a 0 because it is a constant number. So it derivated to 0.
In calculus, theorem of the right is used to discuss the function of the display style f open brackets x close brackets equal x at any time if the value display style r is a real number because the differential is the linear operation in the identity function of the policy. Polynomials can also be addressed using the rule. Okay, number 3.
Rank function differentiation. We all know that the formula is dy by dx equals n times u, n minus 1 times u prime. So the examples are y equals 4x cubed plus 5 inside a bracket square. So if u equals 4x cubed plus 5, that means u prime or u derivative equals 12x squared, because we all know 3 times 4 equals 12 and 3 minus 1 equals 2, so 12x squared. And 5 is a constant number, so it's a 0. And y equals u squared, and y prime equals nu, n minus 1 times u prime. So let's put on the number. 2 times 4x cubed plus 5 as u, and then times with 2 minus 1, and that is the 2 is from the power of number square outside the bracket, remember? So 2 minus 1 means 1, and we times it with 12x squared, and we got the answer is 96x, the power of 5 plus 120x squared.
Differential of multiplication constant to function. Y equal key times v semicolon v equal g open brackets x close brackets. Then dy per dx equal key times dy per dx 14. The duration of the function is the rules of multiple function of some. Function is strictly different from the previous function rules, not that the function of the function is alternatively derived from its function.
Function multiplication differentiation. So the examples are y equals 4x squared times x cubed. So we search for u. U is like the gx, so it's one of the variables, one of the numbers with variables. So that is 4x squared. And if u is 4x squared, what is the u prime? What is the derivative of u? So we times 4 with 2. 2 from the power of number, or we call it square. So we times 4 with 2, that equals 8. And in the power of number, or square, we minus it with 1. It leaves us with 1. And usually, if it left with 1, we don't write it. So it's only 8x. 8x is the derivative of u. And next, v. V is like the hx, or the other numbers with variables. So let's see. That means v is x cubed. So we need to find the derivative of v, or v prime. It is 3x squared, because as I said before, the formula, we brought down the cube, we times it with x. So 3 times x, 3x, and the power of number 3, we minus it with 1. It left with 2, so 3x squared. So the formula to find this multiplication function is y derivative, or y prime, equals to u times v prime plus v times u prime. So that means we'll just need to put it down. So 4x squared times 3x squared plus x cubed times 8x. We count it on both sides, that is 12x power number of 4 plus 8x power number of 4. Because both have the same power number, we can count them, and that gives us the number of 20 and the power of number 4. The answer is 20 and power of number 4. So y prime, or derivative of y, is 20 the power of number 4. 20x the power of number 4. So the answer is 20x the power of number 4.
Okay, number 4. Differentiate constant with function. Y equal key per v, semicolon v equal g, then dy per dx equal minus key dy per dx per v v2 v pangkat 2. The derivative of function on the division of this function is similar to multiplication, differs only in the direction and shape of the fraction.
Differentiation of constant division by function. So the formula is y prime, or derivative of y, equals to negative k, or constant number, times with derivative v respects to dx, and we divide it with v squared. So the examples are y equals 5 by x cubed. What we're going to do is we're going to search for y prime. So remember, the constant number here is 5. So we use 5, we times it with dv, or derivative of v, and that is x cubed. So it becomes 3x squared. So negative, remember, because it's division, so we change the constant number into negative. So it is negative 5 times 3x squared divided by x cubed. But the twist is, we also gives it square. So x cubed square. So we count all of it. We count the upper part first and we get negative 15x squared. And the bottom one, we get x the power of 6. So y prime, or derivative of y, equals to negative 15x squared by x the power of 6.
Differentiation of sum or function direction. Y equal U plus V semicolon U equal G open brackets X close brackets V equal H open brackets X close brackets, then dy per dx equal du per dx plus dv per dx.
Differentiation, addition, or subtraction fraction. So let's start to the example. Y equals 4x squared plus x cubed. So if u is 4x squared, that means u prime equals 8x. And if v is x cubed, that means v prime is 3x squared. Remember how we do it? Because we put down the power of number, we times it with x, and also we decrease the power of number by minusing it with 1. So we get u prime is 8x and v prime is 3x squared. So let's get on to finding y prime, or derivative of y. So the formula is v prime plus v plus u prime. So we just add the derivative of both u and v, and voila, we get it. So it's as simple as that. The answer is 3x squared plus 8x.
Differentiation of multiplication function. The multiplication of derivatives is divided into two cases, namely multiplication function with salary number and limit, multiple function of two function, derivatives from multifunction function with multiplication function with salary number can be promoted. F open brackets x close brackets equal key times u open brackets x close brackets. F petik open brackets x close brackets equal key times u petik open brackets x close brackets. In contrast with the degeneration of sum and education of two function, the degeneration of two function use the differentiation of x function, which is the latter reflected in the formula. F open brackets x close brackets equal u open brackets x close brackets times f over v open brackets x close brackets f petik open brackets x close brackets equal u v petik plus u petik v.
Differentiation of constant multiplication by function. As we know, constant number we symbolize as k, and function we symbolize as we. We, or variables numbers with variables. And the formula for this one is k times derivative of v respects to x. So the examples is y equals 5x cubed. First thing first to do, we separate them apart. So 5 and x cubed. First, we derivated the x cubed, so we brought down the 3 to times it with x. 3 times x, and what's left is 3 minus 1. So it gives us 3x n squared. So 3x squared. And the other side we have 5. So we times it. 5 times with 3x squared. It gives us 15x squared. So derivative of y or y prime is 15x squared.
Number 7. Differential of functions sharing. Amongst the set of the multiplication derivative of the division of two functions shown or lower as function. Then substitute division formula as follows. Open brackets s, close brackets equal to open brackets x, close brackets. So the open brackets x, close brackets, and repeat open brackets x, close brackets. As well, you repeat b minus u titik b minus p titik q per p pangkat 2. Mention the function of the climb rule. The rule of the climb to the offspring of a function is an derivative which is carried out in succession of the function. The rules of the chain are mathematically written as follows. Suppose you are the function in x and y, there you are Cardiff solves. dy per dx equal dy per dx times du per dx.
So, function division differentiation. The formula is y prime or derivative of y equals v times u prime minus u times v prime divided by v squared. So let's just get started with the example. If y equals u by v, and that is y equals 4x squared by x cubed, that means u is 4x squared and v is x cubed. So the derivative of u is 8x because we brought down the power number and we times it with 4. So 2 times 4 equals 8. And the power number we minus it with 1. And if left with 1, and we don't really write it down, so it is 8x. And for the v prime is 3x squared because x cubed, we brought it down, so 3 times x means 3 times x gets 3x, and the power of number we minus it with 1, it equals 2, so 3x squared. And we follow the formula. Y prime or derivative of y equals to x cubed times 8x minus 4x squared times 3x squared. But remember, we have to divide by x cubed squared. So the next is 8x, the power number 4, minus 12x, the power number 4, divided by x, the power number 6. So it is negative 4x, the power number 4, times x, the power number negative 6. So before we have to divide it x, the power number 6, but we brought it up so we can times it, and it changed. The power of number 6 becomes negative. So the answer is negative 4x negative squared. So it is negative 4x negative squared. So y derivative or the y prime is Negative 4x negative square.
Number 9. Differentiation of logarithm function. The simplest logarithm function is the basic x diagram of the number of x. The following diagrams of logarithm function of the simplest logarithm function from y equal pangkat a log x, y petik equal 1 per x pangkat a log a, y equal a pangkat 9 open brackets x close brackets, y petik equal g petik 1 open brackets x close brackets a pangkat 9 open brackets x close brackets times in a.
Logarithmic function differentiation. So the examples are y equals the power of 5 log 7. That leads to derivative of y equals to 1 by 7 in 5. Because 7 in 5 is the 5 is the power of number 5 and 7 is after the log. So we put it in the front and we put the 5 in the back. So the answer of derivative y or y prime is 1 per or 1 by 7 in 5. Or you can answer derivative y with respect to x equals to 5 log e per 7. And keep in mind that e is 2,71828. But either way, the answer is done.
Number 10. Differentiation of logarithmic composite function. Y equal pangkat a log pangkat a log u semicolon u equal g open brackets x close brackets, then dy per dx equal pangkat a log e per u times du per dx.
Logarithmic composite function differentiation examples are y equals log, in brackets there's x plus 5 by also in brackets x plus 7. Then in this example is u equals to x plus 5 in brackets by x plus 7 in brackets. So derivative of u respect to s is x plus 7 times 1 minus x plus 5 times 1 and then by x plus 7 in brackets the power of number 2 or square. That leaves us 2 by x plus 7 in brackets square. And then derivative of y respect to s x is log e by x plus 5 by x plus 7 in brackets times 2 by x plus 7 in brackets. So do you gets it? So we times the derivative of u with the log e so that we can find derivative of y. So the answer is, when we times it, 2 times log e equals to 2 log e by x plus 5 times x plus 7 in brackets. Because if we times it, x plus 5 times x plus 7, because the x plus 7 there's a square, so we can dismiss it, and then the x plus 7 that we're dividing is gone because it is only 1, and then the upper one, x plus 7, the square loss and become the power of number become 1 and we don't write it. So the answer to derivative y respects to x is 2 log e by x plus 5 in brackets, that means times x plus 7 in brackets.
Differentiation of logarithmic composite function is right. Y equal open brackets pangkat A log U close brackets pangkat N, where U equal G open brackets X close brackets N equal constanta. Then dy per dx equal N open brackets pangkat A log U close brackets pangkat N minus 1 time pangkat A log E per U time du per dx.
Rank logarithmic composite function differentiation. So the formula is for derivative y respects to x is n times a log u in brackets n minus 1. Now n is as the power of number, and times a log e by u times derivative u respects to x. So the examples are y equals to log 6x squared in brackets the power of number 3, or it's also called q. So the u is 6x squared, and we're going to find derivative u respects to x, and that is 12x. Because we bring down the power of number, we times it with 6. 2 times 6 get 12, and then 2 minus 1 is 1, and we don't write it, so 12x. Now we're going to find the derivative y respects to x. As I said earlier, there's the formula. So 3 times log 6x squared, and the earlier n we minus with 1, so it is 2. So it is 3 times log 6x squared in bracket square times log e by u, and u is 6x squared, and we also times derivative u respects to x, and that is 12x. So if we mix them together, we get 36x times log 6x squared in bracket square times log e by 6x squared. And if we simplify it, that gives us 6 times log 6x squared in bracket square times log e by x. So the answer is 6 times log 6x squared in bracket square times log e by x.
Next, number 12. Differential composite function Napier. Log Napier, the logarithm is just e equal 1,71828. Use it to the right with pangkat a log a equal in a, y equal in u, semicolon u equal g open brackets x close brackets, then dy per dx equal 1 per u time du per dx.
Napier logarithmic composite function differentiation. So the examples are y equals to in 5x squared plus 7 in brackets. That leaves us to u equals to 5x squared plus 7, and we search for the derivative of u, and that gives us 10x. Because remember, the power of number we brought down, and then we times it with 5, so it is 10, and that leaves us with 10x. Because 7 is a constant number, so it will be 0. So the derivative of y respects to x equals to 1 by 5x squared plus 7, and we times it with derivative of u that we already found, and that is 10x equals to, we got the answer, 10x by 5x squared plus 7.
definition of logarithmic composite function rank. Y equal open brackets in U close brackets pangkat N semicolon U equal G open brackets X close brackets semicolon N equal constanta. dy per dx equal N open brackets in U close brackets pangkat N minus 1 times 1 per U times du per dx.
Rank name here logarithmic composite function differentiation. The examples are y equals in 3x squared in brackets and then the power of 4. The u is 3x squared and we search the derivative of u respects to x, that is 6x, because the 2 we brought down and we times it with 3, that gives us 6, so 6x. And derivative of y respects to x is 4 times ln 3x squared and then cube. Why is it 4? Because we brought down the 4, the power of number 4 we brought down, we times it, and then it left us the part number of 4 in the upper, we minus it with 1, and it gives us 4 times ln 3x squared in brackets, and then there's cube. We also time this with 1 by 3x squared times 6x. So derivative of y respects to x equals 8x times ln 3x squared in brackets and then cube. So the answer is 8 by x times ln 3x squared in brackets cube.
Number 14, differentiasi complex function. Y equal U pangkat V semicolon U equal G open brackets X close brackets and V equal H open brackets X close brackets. Then dy per dx equal V times U pangkat V pangkat V plus 1 V minus 1 du per dx plus U pangkat V in U dy per dx. Suppose V open brackets Z close brackets is a complex function with the home region, domain of dy cc and 20 euro, interior open brackets d close brackets. The function open brackets z close brackets is set to the differential open brackets can be differentiated or differentiated in the zoo if lim az equal ax plus lay. IAY.
Complex function differentiation. The examples are y equals to 7x, the power of number x with the power of number 5. So the twist is the power of number actually have a variable that is x with the power of number 5. So what we're going to do, we're going to search for u and v. The u, we use 7x, and the derivative of u is 7 because we brought down the power of number from x, that is 1, we brought down, we times it with 7, that gives us a 7. Since we minus 1 with 1, it equals 0, so the x be gone, and that leaves us with 7 as the derivative of u. and we as x with the power of number 5. So we're going to search for the derivative of we, and that is 5x with the power of number 4, because 5 we brought down we times with x, that is 5x, and 5 we minus with 1, that leaves us with 4. So 5x with the power of number 4. Now we're going to search for the derivative of y respects to x, or y prime, equals to x with the power of number 5 times 7x with the power of number x with the power of number 5 minus 1, because the formula says we minus 1. Okay, and then we plus it with 7x with the power of number x with the power of number 5 and 7x times 5x with the power of number 4. So what we get here is 49x with x5 plus 4. So earlier the x with the power of number 5 is minus with the negative 1. So it is 4. So that gives us 49x with the power of number x5 plus 4 plus 35x with the power of number x5 plus 4 in times 7x, and the answers are 35x with the power of number x5 plus 4 in brackets 7 by 5 plus in 7x.
Is exact with next diferensiasi function balikan. If y equal f open brackets x close brackets and x equal g open brackets y close brackets, this function yang berbalikan, then dy per dx equal 1 per dx per dy. The feedback means we flip the domain into the rank, instead the rank into domains, creating inverse function. V open brackets x close brackets is f open brackets x close brackets is f minus 1 open brackets x close brackets.
Opposite function differentiation. The examples are x equals to 10y plus 3y with the power of number 4. Now, it is actually the same, but we're changing the derivative of y to be derivative of x. So, we're searching for derivative of x with respect to y. That is 10 plus 12y cubed. It is still the same. We brought down the power of number and we times. So y actually have 1. So we brought down 1, we times with 10. And then it left us with 10 because the y have no more power of number, because 1 minus 1 equals 0. So the y is gone. So that is 10 plus 4 times 3, that is 12. And 12y, 4 minus 1, that is 3. So 12y cubed. So the derivative of x respects to y is 10 plus 12y cubed. And that leaves us, because we're going to find the derivative of y respects to x. So what we're going to do is we put the 1 by 10 plus 12y cubed. This will make it right. So the answer for derivative of y respects to x is 1 by 10 plus 12y cubed.
Okay, so for my part, I'm gonna explain 5 examples of exercise from the first derivative function. For the first example is, we're gonna derivative those equation. For the 5x power of 2, so we're gonna enter the power first, 2 times 5 times x, and for the power is gonna minus 1, so 2 minus 1 minus this 8x is the power is 1, so we're gonna enter 1 times 8 times x, and for the power is gonna be 1 minus 0. It equals to 0. So we're gonna not entering the x later because the x is gone, and plus 0 because of derivative of 9 is 0. And so for the result of f(x) of this equation is 10x minus 8. For the second example of the first derivative function is on this equation, we're gonna divide it into two, which is u and v, and we're gonna find those two into their derivatives too, or we can say as u accent or v accent. And for the u is x power of 5 plus 2, and for the derivative of or the u accent is the power of x, which is 5 times the x itself, and for the power is we're gonna minus it 1, which is 5 minus 1, and it remains the u derivatives or u accent is 5x power of 4. For the second one is the v, it's x power of 2 plus 6x minus 1, and for the derivatives of v or the v accent is the power of x, which is 2 times the x, and the power is 2 minus 1, which is it remains 1, and the derivative of 6x is 6. So the v accent in it remains 2x plus 6. So to continue the solution, we're gonna use fx accent equals to u accent times v plus v accent times u. And for the equation is equals to 5x power of 4 times open bracket x power of 2 plus 6x minus 1 close bracket, and plus the other of the equation is 2x plus 6 times open bracket x power of 5 plus 2 close bracket, and it remains 5x power of 6 plus 30x power of 5 minus 5x power of 4 plus 2x power of 6 plus 4x plus 6x power of 5 plus 12. And the result of this function is 7x power of 6 plus 36x power of 5 minus 5x power of 4 plus 4x plus 12. So for the third example, we're gonna divide those into two as well, which is u and v, and don't forget we're gonna find those derivatives or their accent. For the u is 2x minus 4, and its derivatives is 2, and for the v is x plus 1, which the derivatives is 1. For this solution, we're gonna use the equation, the function of fx accent equals to u accent times v minus u times v accent divided by v power of 2. So it equals to 2 times x plus 1, and the other equation is minus 2x plus 4 times 1. And we're gonna divide it with the equation of x plus 1 power of 2. So it remains 2x plus 2 minus 2x plus 4 divided by equation of x plus 1 power of 2, which it remains 6 equals to equation of x plus 1 power of 2. For the fourth example, we're gonna make those root wobble into the simpler one, which is 4x power of 2 plus 2x minus 9, and for the power is 3 per 4. Where do we get those? Is 3 from the power of the equation, and for the divided by 4 is from the fourth of the root. And the equation is we're gonna derivatives just those equation without the power is it remains 8x plus 2 times the power of the equation is 3 per 4 times the equation exact one is 4x power of 2 plus 2x minus 1, and for the power is we're gonna divide minus 1, which it remains for the power is minus 1 per 4. So for this point, the answer is already correct, but we can make it into other model, which is same as the question is the roots. So we're gonna divide this 3 per 4 3 is with the equation of 8x plus 2 divided by the equation of those power that is minus. It's gonna be entering into the bottom one, which is 4 times open bracket 4x square of 2 plus 2x minus 9, and for the power from before is minus, so it's already changing, so it remains 1 per 4. Then the result is 24x plus 6 divided by 4 times the fourth root of 4x power of 2 plus 2x minus 9. For the last example of this first derivative function is we're gonna make those equation itself into u. So u equals to 5x plus 3, and for we're gonna find those derivative of, or it's u accent it equals to 5, and for the n we're gonna enter it 6. And for this solution we're gonna use this function of fx accent equals to n times u accent times u, and for the power is n minus 1. So it equals to 6 times 5 times 5x plus 3, and for the power is 6 minus 1, which is 5. And for the result is equals to 30 times open bracket 5x plus 3 power of 5.
Determinative function of the variable is the differential of one variable with other maintaining constant. For explain, the first step is a function of the of two chunks x and y if y are at the constant type and y equal y 0, then f open bracket x comma y 0 becomes the function of 1x limited. X 0 is the called equal x 0 is called vertical differential of x in open brackets x 0 comma y 0 plus brackets is equivalent fx open brackets x 0 comma y 0.
Partial derivative. As we know, there's two formula, and in this book formula we need to find both variables, but one by one. So let's just jump right into the example. Y equals 2x squared minus 3z cubed plus 10xz minus 15. So the first question is to find y to x. Now, because we focus on finding this y, means we acknowledge z as a constant. Therefore, when we derivative the z, it will be 0. Remember, we need to focus on one side at a time. So, ay by ax equals to 2 times 2x squared. Remember, because the power of number 2 we brought down and we times it with 2x, because 2x is the constant number but we have a variable, so 2 times 2 gets 4x, and 2 minus 1 equals 1, so it's only 4x, and we minus 0, because remember 3z cubed, there's z, and I explained earlier that we focus on x. So z we consider as a constant number, so we makes it a 0. So 4x minus 0. Now we plus to 10x z. First we are focusing on x. So 1 times 10 1 is from the part of number from x, so it is brought down, and it's still the same, so it's still 10x. But because there's we minus the 1 with minus 1, the x is gone, because it actually didn't write any part number, and we consider it as 1. When 1 minus 1, it is 0, so the variable of x is gone because it is 0, so it leaves us with 10z and minus 15. 15 is a constant number, that means a 0. So the answer for y2x is 4x plus 10z. And let's move on to y2z with the same question, but now we're focusing to find the z. So ay by ax. Remember, because we focus on z, so that means every axis we consider it as a constant, so it is 0. So 2x squared becomes a 0. And now we can count on negative 3z cubed. 3 we brought down, we times it with negative 3z. That gives us negative 9z squared, because remember, the power of number 3 also minus 1, so it is negative 9z squared plus 1 times 10. Where's the 1 come from? It comes from the power of number z. So now it is 10, but remember, the z in the question also don't write any power of number, so we consider it as 1. But 1 minus 1, because it is the rule, it is the formula, the power of number must be minus 1. And 1 minus 1 means 0, and it leads the z to be gone. So it's what's left is just 10x. And as earlier, it's still the same. Negative 15 is a constant number, so it is 0. So the answer is negative 9z squared plus 10x for the y2z derivative.
Differential total. Differential might be interpreted as a change in the function of free variable change. Then differential might be interpreted as the change rate of each a variable in response to n change in variable a. The total differential of a function can mean the gradient of that function, with repression the sum of all the partial. Differential of all the independent variables is a major part of the change in a as a result of this change in x I independent variable. The formula y dengan delta y per delta x1 dx1 ditambah titik delta y per delta xn dikali dxn. It is a function that can be differentiated. By definition, it can be differentiated incrementally, where the element of error, term error, and I is near 0 because increment and x going together near 0. So the total differential can be strictly defined as the I dy sama dengan delta y per delta xi sama dengan delta xi ditambah titik delta y per delta xn dikali delta xn.
Okay, total differential. So the examples, we have to find the total derivative of fxz equals x squared plus 3xz squared minus 5z cubed. So the first one is fxxz equals 2x, because we brought down the power of number, so it 2 times x, and 2 minus 1 is 1, so we don't write it down, so 2x plus 3z squared, because we have to look that it's actually 3x and we brought down the power of number, so it 1 times 3 left us with 3, because the x have no power of number anymore, so it is gone, so it's just left us with 3z squared. And remember, we have to focus on x, so negative 5z3, it's a constant number, it is gone. And next is we focus to fz xz equals to 6xz, because x in the question x squared is gone because it is constant. We focus on z, so 3xz squared, we times 2 to 3, it gives us 6xz, and we minus it with 3 times 5, gives us 15z squared. And because we're looking for fz, that means the x change, okay, to a constant. Don't forget about that. And now, after we got both answers, we'll just need to add them up. So derivative of y equals to 2x plus 3y squared plus 6xz minus 15z squared. So the answer is 2x plus 3y squared plus 6xz minus 15z2.
Implicit function. There is a function which is that the function of a free and unfree variable mixes in one join and cannot be separated in a different number. There are two ways to solve for the derivative of the implicit function. First, make modification to implicit function that become an explicit function, and then solve for its derivative as in implicit function. Second, lower the point of implicit function expression and simply to get the desired result. That's formula x pangkat 2 ditambah f dalam kurung x pangkat 2 dikurang 1 sama dengan 0, x sama dengan variabel bebas, f dalam kurung x sama dengan fungsi x.
Implicit function. The examples are x squared plus y squared equals 9. So the things we do is we put brackets on both numbers, and that is like d respect to x in brackets of x squared plus y squared and close the brackets, and then equals to derivatives respects to x. Inside the bracket there's 9, and we brought this down, and remember 9 is a constant number, so we write it as a 0. And what we're going to do is we from the left side we give both of x and y their derivative. So derivatives respect to x, x squared plus derivatives respects to x, y squared, and this gives us a place to derive them, and x squared becomes 2x, because of course you already know 2 times x and then 2 minus 1, and it becomes 2x, plus we brought down the y, but remember this is with respect to x, so it is 2y times y prime to make it even, equals to 0. And then what we're going to do is 2y times y prime equals to negative 2x, so that we can count this. And at the last moment we put y prime, or derivative of y, equals to negative 2x by 2y, and we can minimize them, and the answer is negative x by y.
For this part, I'm gonna explain about the example of equation for partial derivatives, total differential, and the implicit function. For the first example is to determine those first partial derivatives. So for this equation, we have to find those fx of xy and the fy of xy. And for the fx of xy, we're gonna derivatives all of the equation that there's x1. So for the x power of 3, it's the derivatives is 3x power of 2, plus for the 2xy, we're gonna derivatives the x1 only, so it remains 2y plus, and for the 5y power of 2 minus n minus 2y, it's y, and there is no x1, so we're gonna enter it 0, and it remains the fx of xy is 3x power of 2 plus 2y, and for the fy of xy is we're gonna derivative those y only. So for the x power of 3, and it remains 0, and plus for the 2xy we're gonna derivative the y1 only, so it remains 2x, plus for the 5y power of 2 it remains 10y, and the derivatives of 2 minus 2y is minus 2, and the final of the fy of xy is 2x plus 10y minus 2. For the next example, we're gonna determine those second partial derivatives of those equations. So for this part, we're gonna do the same thing as before, is find those first partial derivatives, which the fx of xy is derivatives of the x1, which is x power of 2, which is 2x, plus for the y, x and y, the derivatives is y, and for the y power of 2 is 0, and it remains fx of xy is 2x plus y, and for the fy of xy it equals to for the x power of 2 is 0, and for the xy it remains x, and for the y power of 2 it remains 2y, and the final of fy of xy is x plus 2y, and for those fx of xy and the fy of xy we're gonna derivatives those again, and it calls the second partial derivatives, which is the fxx of xy is 2, and for the fxy of xy is 1. For the fyx of xy is 1, and for the last one is fyy of xy is 2. For the third example is the total differential one, which the equation is z equals to x power of 2 times y power of 2, and for the answer is dz equals to the derivatives of x is 2x y power of 2 dx, plus since it was total we're gonna plus which with the derivatives of y, which is 2x power of 2 times y times dy. For the fourth example, it was the implicit function, so for this equation we're gonna make it those into fx equals to 0, which is 3x power of 2 plus y minus y power of 3 plus x equals to 0. So we're gonna derivatives those x and y's, and but special for the y we're gonna times those with dy per dx. So the derivatives of 3x power of 2 is 6x, plus the derivatives of y is 1 times dy per dx minus the derivatives of y power of 3 is 3y power of 2 times dy per dx plus 1 equals to 0. So we're gonna make those into dy per dx equals to blah blah blah. So we're gonna factorize the dy and dx equals to open bracket 1 minus 3x close bracket times dy per dx equals to minus 6x minus 1. And we're gonna move those factorized one from the dy per dx, move it into the right side. So it remains the final answer is dy per dx equals to minus 6x minus 1 divided by 1 minus 3x. For this last example, it was also implicit function. So for this equation, we're gonna solve those first. Then we're gonna derivatives those x and y. So the derivative of 2x power of 2 is 4x plus the xy. How can we derivative those xy? So we're gonna determine the x1 is u and for the y1 is v. So we're gonna use the function of fx equals to u accent times v plus v accent times u. So for the u accent is 1 times the v1 is y plus the derivatives of v, it was 1 times, but it was y, so we're gonna add times the x dy per dx times the u is x. Then we're gonna minus, go to the next one is the derivatives of 3y power of 2 is 6y times don't forget it was the y1, so we're gonna add dy per dx equals to the derivatives of 40, it's 0. So it remains 4x equals to y plus, and for the dy and dx is x minus 6y close bracket times dy per dx. So we're gonna divide those into dy per dx equals to the blah blah blah. So x minus 6y times dy per dx equals to minus 4x minus y. And for the equation for dy dx, we're gonna move it into the right side. So the remain of this final answer is dy per dx equals to minus 4x minus y per x minus 6y. So that's all for our derivative function PPT and the explanation. Thank you and goodbye.